Solar system origin, interior, and age of the Earth. Origin of the solar system. Theories like the nebular hypothesis and the Big Bang theory explain the formation of the solar system. Interior of the Earth. Earth's structure is divided into the crust, mantle, outer core, and inner core. Seismic waves help understand the layers. Age of the Earth. Radiometric dating, especially with isotopes like uranium-238, places Earth's age at approximately 4.5 billion years. Weathering types and products. Mechanical weathering. Physical breakdown of rocks, for example freeze-thaw, exfoliation. Chemical weathering. Breakdown of minerals through chemical reactions, for example, oxidation, hydrolysis. Biological weathering. The role of organisms in breaking down rocks, for example roots growing into cracks. Products of weathering. Soil formation, regolith, clay minerals, and various weathered rock fragments. Geological work of wind, rivers, seas, and groundwater. Wind. Erosional features, for example dunes, deflation basins, and depositional features, for example loess. Rivers. Erosion, e.g., valleys, canyons, transportation, and deposition, for example deltas, floodplains. Seas. Coastal erosion, longshore drift, and depositional landforms like beaches, spits, and sandbars. Groundwater. Karst topography, for example caves, sinkholes, and erosion through chemical dissolution of limestone. Causes and effects of volcanoes and earthquakes. Volcanoes result from the movement of tectonic plates. Causes include subduction zones, rift zones, and hotspots. Effects. Lava flows, ash clouds, pyroclastic flows, and volcanic gases. Earthquakes. Caused by the sudden release of energy along fault lines or volcanic activity. Effects. Ground shaking, surface rupture, tsunamis, landslides. Seismic zonation and Richter scale. Seismic zonation. Division of regions based on earthquake hazards. India, for example, has zones from Zone 2, least risk, to Zone V, highest risk. Richter scale measures the magnitude of an earthquake. It is logarithmic, meaning each whole number increase represents a tenfold increase in amplitude. Principles of plate tectonics. Earth's lithosphere is divided into tectonic plates that float on the asthenosphere. Plate movements result in various geological phenomena. Divergent boundaries. Plates move apart, for example, mid-ocean ridges. Convergent boundaries. Plates move together, for example subduction zones, mountain formation. Transform boundaries. Plates slide past one another, for example San Andreas Fault. Island arcs, deep sea trenches, and mid-ocean ridges. Island arcs. Chains of volcanic islands formed above subduction zones. Deep sea trenches. The deepest parts of the ocean floor, found at convergent boundaries. Mid-ocean ridges. Underwater mountain ranges formed by seafloor spreading at divergent boundaries. Continental drift evidence and mechanics evidence. Fossil distribution, matching geological formations, and the fit of continental coastlines, for example South America and Africa. Mechanics. Driven by mantle convection. Continental drift was first proposed by Alfred Wegener and later developed into plate tectonics. Seafloor spreading, a process by which new oceanic crust forms at mid-ocean ridges and moves outward. It provides evidence for plate tectonics and continental drift. Isostasy, orogeny, and epeirogeny. Isostasy. The equilibrium of the Earth's crust floating on the denser mantle. Orogeny. The process of mountain building through tectonic forces. Epeirogeny. Large-scale vertical movements of Earth's crust that result in continental uplift or subsidence. Continents and oceans. Fundamentals of geomorphology. Geomorphology. The study of landforms, their processes, history, and the structures that form them. Fundamental processes include erosion, deposition, tectonics, and volcanic activity. Continents and oceans. The distribution of land and water is shaped by plate tectonics and processes such as isostatic adjustment and seafloor spreading.